On 305, we have an A and a B. And in exploration 1, it says if you roll a 6-sided dice, then event A is an even number and event B is a prime number. There is one number that overlaps, and that's a 2. A contains 2, 4, and 6. B contains 2, 3, and 5, and they share a 2. So if you look down at exploration 2, if we roll one 6-sided dice, and in letter A, event A is an even number and event B is a prime number, what's the probability that A happens? So if I roll one dice, what's the chance that A happens? Well, how many numbers are in A? 3. How many numbers are there total? 6. So 3 out of 6 would be 1/2. Okay. What's the probability that B happens? 3 out of 6. It's the same thing. Now, the probability that A and B both happen. How many ways are there for A and B to both happen? Yep. What is the probability that A and B both happen? Well, how many ways are there for A and B to happen? Just one. The only way that A and B happen is if the answer is 2. So there's one way for it to happen out of 6. So the answer would be 1 out of 6. What about A or B? What does A or B mean? So let's say you were betting on this. You're rolling a dice. And if A happens or if B happens, you win. How many ways are there for you to win? Well, if you roll a 1, do you win or lose? Lose. Why? Because 1 is not in A and 1 is not in B. Okay. If you roll a 2, do you win or lose? Win. How come? It's in A and it's in B. Okay. If you roll a 3, do you win? Yes, because it's in B, so that would be a win. If you roll a 4, do you win? Yes, how come? Because it's in A. If you roll a 5, do you win? Yes, because it's in B. If you roll a 6, do you win? Yes, because it's in A. So what's your chance of winning? 5 out of 6. That's a good game to play. All right, now, here's where you have to be careful. What is wrong with this statement? The probability that A happens is 3 out of 6. The probability that B happens is 3 out of 6. So the probability of A or B should be 3 out of 6 plus 3 out of 6, which is 6 out of 6. I counted the overlap twice. So A or B, we have to be careful that we don't count something twice. Remember when we did the two-way tables? The probability that you are male and the probability that you like your height? You can't add all of the height people with all of the males because there's one box that gets counted twice. So if there is an overlap, then you have to be careful when you do the OR. What if there's no overlap? Then the probability of A or B, can we just add the A's to the B's? Yes, because the overlap doesn't exist. Okay, so on exploration 1, letter B, A contains a 2 and a 4, and B contains an odd number, 1, 3, and 5. What is the probability? So now going down to exploration 2, what is the probability that A happens? 2 out of 4. There are 2 numbers in A, and there are 2 2 out of 6. Okay. What's the probability of B? 3 out of 6. Okay. What's the probability of A and B? How many ways are there to get A and get B? None. It can't happen. There's no overlap. If there is no overlap, what do we call that? Disjoint or mutually exclusive. Okay? Probability of A or B. That's just going to be 3 out of 6 plus 2 out of 6, which is 5 out of 6. Right? Everything that A has and everything that B has added together. Right? Why do we not have to be careful in this case? There's no overlap, so nobody gets counted twice. Okay. Look down at exploration 3. In general, if event A and event B are disjoint, then what is the probability that A or B will happen? If A and B are disjoint, so here's A and here's B, how do we find the probability of A or B? We just add the A's to the B's. So it's just the probability of A plus the probability of B. Does that make sense? Okay. I don't think it asks. But what is the probability of A and B? 0. And this is a really important idea. If A and B don't share anything, then the probability of A or B is simply the probability of A plus the probability of B. Okay? And if A and B are mutually exclusive, then the probability of A and B will always be 0. It never happens. Right? There's nothing that they have in common. Okay. The next one asks, if A and B have some overlap, what is the probability of A or B? How do we find it? How do we find A or B if they overlap? How did we do it with the numbers that we just dealt with? What's that? So we have to make sure we don't count the middle twice. Now let me give you some notation. This here is called the probability of A. Okay? This here is called the probability of B. What do we call this? What do we call it when two things touch? If we have two graphs and they hit each other, what do we call that point? The intersection. Okay? And the intersection, the symbol for intersection is like an upside down U. So this is the probability of A intersect B. It's kind of like an upside down horseshoe. Okay? So, if I don't know what's in there, I don't know how many there are, how would I calculate the probability of A or B? So Maya just said, you count all of A and you count all of B, but, what was the word you used? You don't count the middle twice. You can only count the middle one time. If I do all of A and all of B, what's wrong with that? The middle gets counted twice. So I can just subtract the middle one time. Does that make sense? So, going back up here, if A and B are totally separate, disjoint, mutually exclusive, A or B is simply the probability of A and the probability of B put together. Going down here, if A and B have an intersection, then to find the probability of A or B, we're going to take the probability of A and we're going to add that to the probability of B, but that number is too big. How much too big is it? One copy of the intersection. When I calculate A, that includes the middle piece. When I calculate B, that also includes the middle piece. So the middle piece got counted twice. So all we have to do is subtract the probability of A intersect B. Does that make sense? Okay, we'll do some problems that'll help you understand that. Okay, turn the page. All right. So we have, let me put this up on the screen. Okay. If we look at this, how many dots are there total in the first one? So this one has 13 dots. So let's say every dot was a different number. What is the probability if we reach into this bag and pull out a number that A happens? What is the probability of A? Well, how many dots are there inside A? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of A is 9 out of 13. Okay. What's the probability that B happens? So we look at B, 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 13. Now, let's say I couldn't see the picture. Can I look at those probabilities and determine that A and B have an overlap? How, Tanner? There are 9 A's and 8 B's, and when I add 9 and 8 together, I get 17. What's wrong with 17? It's bigger than 13. Can I figure out what the overlap is without looking at the picture? How big is the overlap? Why 4? Because 17 is 4 numbers too big. So 4 must be the intersection. Do you guys see that? So I can do it without the picture. Okay. So what is the probability of A and B? 4 out of 13. That would be this section right here. And I could actually find that, like we did, by taking 9 and adding it to 8, and we get 17. And 17 minus 13 is 4. Okay. What is the probability? Don't look at the picture. What is the probability of A or B? Well, we have to take all of the A's. How many A's are there? 9. And all of the B's. How many B's are there? 8. So we take 9 and we add it to 8. And then we have to subtract off the intersection. Why? Because the intersection happens twice. So what's the probability that A happens or B happens? 17 minus 4 would be 13 out of 13, which would be 100%, right? Because all dots are either in A or in B. There are no dots on the outside. Okay. Now if we look at this picture, how many dots are there total? 9. What's the probability of A? 5 out of 9. What's the probability of, B? 4 out of 9. Can I tell from those numbers that these are mutually exclusive? Yes. How? 4 plus 5 is 9. So what's the probability that A and B both happen? 0. They don't share anything. Okay. What's the probability that A or B happens? Would be 100%. Because our only choices are A or B. There's nothing on the outside. Okay. All right, example 1. A card is randomly selected from a deck of 52 cards. What is the probability that it is a 10 or a face card? So, A is going to be a 10, and B is going to be a face card. Is there any overlap there? No. So if I make the set of A, how many cards are there in A? 4. What are they? The 10 of hearts, the 10 of clubs, the 10 of spades, and the 10 of diamonds. Okay. In B, what is there? The king of hearts, the king of spades, So the king of spades, the king of clubs, and the king of diamonds. What else? The queen of, and I'm just going to cheat, right? The queen of all 4 suit, oh my goodness. Yeah, that's right. And then the jack of H, S, C, or D. So there are 4 cards in this place. How many are there in B? 12. So what's the probability that A happens? 4 out of 52. What's the probability that B happens? 12 out of 52. What's the probability that A or B happens? 16 out of 52. Do we have to worry about any overlap? No. What's the probability that A and B happen? 0. There is no overlap. Does that make sense? Okay. Example 2. A card is randomly selected from a deck. What is the probability that the card is a face card or a spade? If A is face card and B is spade, are there any overlaps? Yes. So let's deal with the overlaps first. So A is a face card and B is a spade. If I switch those, does it matter? Nope, it's not going to change anything. So which cards are in the intersection? The king of spades, the queen of spades, and the jack of spades. Okay. What else is in A? King of hearts. Oh my goodness. Sorry. I don't know why it does this. Okay, let's try that again. So we said king of spades, queen of spades, and jack of spades. So A is face, and B is, what was it, spades? So we have the king of hearts, the Queen of Hearts, and the Jack of Hearts. What else is in A? The King of Diamonds, the Queen of Diamonds, and the Jack of Diamonds. Anything else? The King of Clubs, the Queen of Clubs, and the Jack of Clubs. All right? What else is in B? The ace, A of spades, the 1 or 2 of spades, 3 of spades, 4, 5, 6, 7, 8, 9, and 10. Does that make sense? Okay. What is the probability of A? So we need to count everything that belongs in A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability of A is 12 out of 52. Okay. What's the probability of B? There are 13 spades, ace through king. So 13 out of 52. Okay. What is the probability of A and B? How many fit both circles? Just 3. 3 out of 52. Now, let's suppose that you can't see this. So without looking at the diagram, what is the probability of A or B? How are we going to find that? Well, it's going to be all of these and all of these minus the intersection. So there are 12 A's and there are 13 B's. What's wrong with adding 12 and 13 together? 3 cards get counted twice. So it's going to be 12 plus 13 minus 3 over 52. Okay. Now, if we're allowed to look at the picture, you can see that. There are 12 cards in that bubble, and there are 13 cards in that bubble. But if I add the A bubble to the B bubble, this interior group, the intersection, gets counted twice. So we do all of A plus all of B minus the intersection. So that would be 12 plus 13 is 25 minus 3 is 22 out of 52. That's the probability of getting a face card or a spade. Okay? All right. Example 3. Out of 200 students in a senior class, 113 are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What is the probability that a randomly selected senior is both varsity and a varsity athlete and on the honor roll? So we have 2 bubbles, and we know that A is a varsity player and B is the honor roll. What is the probability that A happens? How many of those students are varsity athletes? 113. 113 out of 200. Okay. What's the probability of B? Oh, sorry. I did that wrong. We got that wrong. So what's the probability that someone is a varsity athlete? 74. Okay. What's the probability that somebody's on the honor roll? 50 1. And what's the probability of A or B? 113. Okay. Are any kids both? How do we figure that out? We add A and B together. So I take 74, and I add that to 51, and I end up with 125. So are there any kids that are right here? How do you know? 125 is bigger than 113. Can we figure out exactly how many kids are in there? How? 125 minus 113 would be 12. So this would be 12. Now, just to make sure that you understand it, how many kids go in this section? Well, there's 74 in this, but how many of them fit here? 74 minus 12 is 62. How many people fit in here? So it would be 51 minus 12 is 39. Okay, now here's kind of a tricky question. How many people are out here? 87. Why? Well, this many kids land here, here, or here, right? So everybody else must be outside of A and outside of B. So there would be 87 kids that don't fit into any of those blocks. Okay? I don't think we're going to do example 4. Okay. So we're going to do 1 through 16, or sorry, 3 through 16. Three through 16 all. All right, get to work.